This conference will now be recorded.
So what we have covered today, Lalit, basically these are the things that we covered yesterday. What we did is basically we learned about modules. We learned a bit about functions basically also, and what exactly we did also. Yeah, we learned about them, and then we taught ourselves that why do we need functions, how do they help in our code. Then we come to know that a function divides a problem into sub-problem. When we have a complex problem, how we deal with that problem, basically we divide that particular problem into subsection. Right guys, we discussed function yesterday, right? If I'm not wrong, please correct me. Have we discussed function yesterday? I could be wrong. I mean, let me check. It's not the notebook. Compal, Helena, can you tell me what did we cover yesterday? Till what point we've covered? Regression, yeah. Did we did anything else from regression? Yeah, okay, yeah, yes. Function was covered in the last class. Okay. Yes. My bad, guys, my bad. So yeah, Lalit, we've covered another regression model basically. We've covered the regression model on top of the data set that we had. I think you have attended this section of about functions basically. So we've covered, yeah, you've attended this as well about the objects, yeah, dynamic type. So yeah, we did the regression analysis. There was a data set that we uploaded, which was LSD data set. So this data set was collected in 1995 or in 90s basically. It was a research which was conducted by G. Wangler and George K. Afghan. So what they did basically, this they conducted a test in which they were trying to find out the correlation of performance of the test score with the tissue concentration of lysergic diethylamide in a human subject. Basically, they had 5 volunteers and which agreed to sit for a math test, and they injected them with some drug basically, which we call LSD-25. You can Google it up. It's a sort of drug that we use, and they gave them the drug based on their body weights, and we had our data, and they asked them to sit for the test after injecting them with the drug, and they collected the sample of the tissue, what is the concentration of drug in the tissue, and then how well they are performing. So we had this data, yeah, this data set that we are having. So this is the time they injected them with a drug, then they give them 5 minutes, then they asked them to sit for the test, and they got this much score. So I'll talk about this also, how they get scored. Then they check the concentration of the LSD in the tissue. So it was coming out to be this. Then after 15 minutes, it's increasing. Scores are decreasing. This is the time is obviously increasing. It's also increasing. Scores are decreasing, and so on and so forth. So how they collected the score? You can see there is an average score. It's written as average score. So how do we have average here? Oh no, not this one. Yeah, how do we have average here? So basically they have the sample questions which they ask the normal people to attend to also. So let's say they have a few people which attempted the same test. They were not injected with the drug, and then they have these volunteers who were injected with the drug. They asked them to solve the question, and the average they corrected maybe the correct answer was by the controller was 3, and then by them was the 3. How many questions they've corrected? It's 3. Then they are getting the percentage of 33 basically. So they took the percentile. I guess you all are aware of percentile. 3 by 9, so that's 33%, and that's what the marks that we have. at this point basically, you can see. So then we did our plotting and we figured, yeah, then we collected, here. Yeah, then we stored these different data types into LSD, score, and time, and then we imported matplotlib and linear regression. We described our data, we plotted the data. This is how the data looks like, and then we did the linear regression. We got the intercept, the coefficient, the score as well. So we got the score as approximately to 87%. And if we plot our data, this is how it looks after I plot a line on my data points. So these are my actual values, actual score. Over here I have the LSD, LSD ppm, and over here I have the performance score, and this is the line that my model have predicted. So I was getting an accuracy close to 87%. So they have got the accuracy also close to that point only. If you can see, I guess it's the slide is not, yeah, it's there. Yeah, they were getting the accuracy close to 89%. Their intercept was coming out to be 89, and our intercept was coming out to be also 89, and their slope was coming out to be 9.44, and our slope was coming out to be 9. So we were pretty close with what they did. Now today, let's see what we are going to do. Guys, so Lalit, is it clear to you? And I would recommend you to go and check the video, yesterday's video. I guess that will make things better for you. So I have given you the theory of it. Yeah. So today what we are going to do, basically, we are going to look under the hood, basically how actually the machine learns. We will try to understand that today. And we will look into, because as so far what we have understood, basically, that machine learns the parameters as I've talked about, the slope and the intercept basically, but how the machine is going to come to know that which parameters are the best parameters, which parameter is going to give you the best fit line basically. So how that is going to happen, there has to be some mathematical formula which has to be there, which will tell the machine that this is the way you can find out that it is the, I mean, it is the best fit line basically. So in this section we will try to look at the optimization. How can we optimize our algorithm? We'll try to look at the calculus also, some of the calculus. We'll also look into derivatives, how to calculate derivatives, because derivatives is going to help us a lot. Then we'll look into loops, then we will create our own algorithm, and then we will talk about gradient descent also. So I'll tell you what gradient descent is in the further slides. So these are the few topics that we will try to cover. So optimization is basically when you got a regression, intercept and slope value. So then the next part is basically how can you optimize that particular value. So the data science problem solving revolves around it. We get the data, we analyze the data, we visualize the data, then we build our hypothesis how to solve this particular problem, and then we then we select the algorithm, which algorithm we should use for solving this particular problem, whether this algorithm will work for this sort of problem, or whether this algorithm will fail, at what point it will fail, all those things. So let's say after doing all this, we get some parameters. So after we get some parameter, then what we do, maybe we get the accuracy of 60% or 50% or 70%. So our client, or maybe we are not happy with that particular accuracy. So what we have to do, we have to do the optimization of our problem. We have to optimize our algorithm. We have to change some parameters. We have to go back from the starting. Maybe we missed on some data, and maybe we need to collect some more data. Maybe we didn't included such features. So we'll try to keep that in mind, and we go back and we try to do the optimization in that sense. Okay, so let's move on. So this is we'll also talk about this. What is this thing is? This is basically the cost function. For now, you will not understand it, but later on along the session, you will have an idea what exactly this thing is. So now I was saying how machine learns. So basically machine try to predict the parameters, as I said multiple times. The intercept, machine try to predict the intercept, and machine try to predict the slope, basically the orange and the green value basically, and based on that it tries to draw a line on the data points. So based on the intercept and the slope, we could have multiple lines. So let's say this is one of the line, and then I have another line, maybe. Okay, maybe these are the three lines that I have on my what do you say, on my data points. Basically this is the three lines that I have there. So how I can make sure, how can I find that which line is best? What do I have to do for that? I have to, let's say these are the two lines. Okay, let's make it simple. And these are the two lines that I have, and I want to find out which is the best fit line. So looking at this figure, I can clearly say this is the best fit line because it's giving me less error. This is giving no error. But I can look at this and I can tell you about this thing, but the computer, the algorithm cannot understand. So we need some sort of mathematical formula, some sort of mathematical equation to calculate this. And that's when residual sum of squares come into picture. So what do we do with residual sum of squares? I'm just trying to remind you. I know we have already gone through this, but this is very important. You must be thinking that why he is repeating the same thing again and again, because this is very important, and that's why I'm trying to do it. So basically we are calculating the distance from my original value, actual value you can say, and the calculated value. Then I have some difference, I take the square of that difference and I try to minimize that difference. And with this minimization, this gives me the error basically. So how I am going to check the best fit line, the line which is going to give me the least error. But how I will find the least error? That's when the picture comes in as cost function. So I guess you might have guessed it already what the cost function is doing. So cost function is helping me to find out the minimum value of the error. How do I find the minimum value of the error? How do I make sure after this point, if I go on solving this problem more, maybe my error is going to increase. So this is going to be my function. And this is how we design our algorithm, right? This is how we design the algorithm. So what is algorithm? What is algorithm? Let's look at this. So algorithm is basically, I have some mathematical formula which is going to make some prediction. Maybe it is calculating the value for the theta naught and theta 1. If it calculates the value, it will have some line. So I have a line. Now what I will do, I will calculate the error, how well my line is predicting the value from the actual value. I have some error, then what I will do, I will try to adjust those parameters that I have, the theta naught value and theta 1 value. Then I go back, try to make the predictions again. I have a new theta 1, theta naught and theta 1 parameters, and I check them with the original value. I have an error, I try to again optimize it, and this is how the cycle works. So this is, this is basically a very broad picture of any algorithm. This is how any algorithm will work. You can think of machine learning, deep learning, computer vision, any problem that you can think of. This is how that problem is going to be solved. It will make some prediction. The first prediction that it will make, it will be very random, very vague. The next time it will check how bad it is doing, how well it is doing, and based on that it is going to make the next prediction. So obviously the next prediction is going to be better than the first one, and so on. This cycle continues. So this is what a algorithm is, and you all must have heard this word algorithm a lot basically. So let's look at the, what exactly the algorithm is, what Cambridge Dictionary says about the algorithm. So algorithm is a mathematical instructions or rules that are, especially if given to a computer, will help to calculate an answer to a problem. So basically it helps me to solve a particular problem, and it is a sort of equation or a mathematical function. I have to pass in some function to my computer, based on which it will try to minimize that function. I will tell the computer that you have to minimize it. Once it has the minimum value, then take the parameter, whatever the parameter it gives you, and use those parameters for the predictions. So this is, this is very this is like this very alien to us, that this is how actually algorithm works. But this line might be familiar to you. You might have heard of this line a lot, that maybe my app uses an algorithm to predict if fans of one particular band will also like music from another band. If somebody is a music lover or band lover, then they might relate to this particular line. If somebody is not, then you can think of different algorithm, different advertisement that we hear on Instagram, Facebook, YouTube, different. If we heard that YouTube has an algorithm which will push you a content that you can serve more, the likable content or the content that you will consume more. We heard this a lot, that TikTok has this algorithm which will make you an addict. You will not leave that app, you will stick to that particular app. It's designed in such a way that it will serve you those videos which you cannot ignore. You will be watching those videos maybe for hours and hours, and you will not care about whatever the time is. Also, we've heard about the algorithm of the Google Maps, how the Google Maps algorithm works. It's again a minimization problem. It's finding the best path, basically. That maybe how this algorithm works. We all have solved this problem, I guess, when we were kids. Maybe we've solved this puzzle that let's try to look at this. Maybe if you can recall, I have maybe something like this, and how do I put it? Yeah, maybe this. So my point is yeah, somewhere here. So I am at this point basically, and I need to get, or maybe yeah, I need to get at this point. This is my entry, you can say, and this is my exit. I want to exit from this point. So what do we do? Basically, we try to find the best path, or the easiest path, or the shortest path, as we say. So with this path, is it the easiest one? No, it could be the easiest one, but is it feasible? We have to check that. This path is also there, but is it feasible? So this is how Google Maps work basically. This problem Google Maps try to solve. They have some sort of a puzzle designed in such a way. They have designed their algorithm in such a way that it is solving a puzzle. It has to go from point A to point B basically. But how it has to go, how it is going to be different, it is going to give you the shortest path, the path on which there is less traffic, wherein there is less fluctuation of traffic, maybe, where you will reach, following that path, you will reach your particular destination in the shortest time period. And we've also heard about the algorithm of Amazon, how Amazon serves you the product, that recommends you the product that you might, go and buy again and again, maybe. And how Netflix serves you movies, that you will watch based on your previous history, the movies that you might have logged, based on that. They have large amount of data basically. That is the advantage they have huge amount of data. So that means they can misuse that data, and they can also take advantage of data. They can make lots of mistakes. That is the advantage you have when you have large amount of data, when you have large amount of audience. You can do a lot of experiments, you can try out different things. You are not, you don't have this fear of failure basically. So you can try different things, you can take your liberty, you can try out different things. If something works, that is obviously good for the company, that is good for the platform, and obviously it is going to help the user as well. Because whatever you are trying out, but if you are trying out something new for your user, so obviously at the end of the day it is going to help the user at the when it reaches to the final or the finishing product, when you have your finished product basically. maybe the user might find some difficulties along the way, but at the end goal is going to be always thinking of something good. We also heard of this algorithm, how NLP works. NLP, I guess somebody if not aware, natural language processing, how computers understand our language. Basically, how does that work? So because our language is English language, as I say, or Hindi, Punjabi, or maybe Bangla, whatever language you speak. So how does computer understand that language? Because computer only understands zeros and ones. So how does that work? We also have an algorithm for it. We have some mathematical formulas for it, which is going to convert your language to the machine learning language. And you might have seen this also when we try to search something on Google. Maybe I am searching for machine learning, so I'm giving a wrong spelling. I say might be machine, and I might say LARNIN, just something. This is what I say. So Google will tell me, are you looking for, do you mean machine learning? It will give me the correct spelling. How does Google know that I am talking about this? I'm looking for this. So basically Google tries to check the similarity of the word that I'm typing out at that point on Google. And what is the similarity? They have a huge amount of data set which they have. It's approximately around like 1.8 GB. If you go and download it, if you look for it, it's approximately around 1.8 GB or something. So the data, the vocabulary that they have built on, and they will check the similarity between the word that you are trying to search for and whatever that word is similar to. Also, this is how Grammarly works basically. If you, some of you have used Grammarly, so they are also using this NLP technique, checking the similarity and giving you the output. So this is what the algorithms are. But if I talk to a person who is not aware about computer science, who is not aware about about data science, who is not aware about these terminologies, so what he if once he heard this term algorithm, for him it's like an alien term for him. So he might think, it's a very, somebody is doing something cool, which nobody can do obviously. So you can think, he will think of that this is the programmer technique of a programmer when he is not ready to share with you what exactly he is doing. Something, if you have an app maybe which can predict my mood maybe, or which can recommend me some books. So you will say, okay, I'll ask you that okay, so Lalit, you have created this app and it recommends me very good books, I mean the books that I obviously going to read. And maybe you have an app which recommend me some article, news article, which I read a lot. So if I come and ask you, Lalit, can you tell me how you do that? You will say, actually, we use a sophisticated algorithm. You will use such sort of vocabulary that the person will feel like, oh yeah, he's doing something cool. I mean, yeah, obviously it's going to be tough because he's doing it, and obviously he's doing something cool. So algorithm is something, if somebody don't want to share with you what exactly they are doing, that's when they use this term basically, or a particular programmer, he's going to use this term. So as I said, we try to, our algorithm, what is the function of my algorithm? Basically to minimize the error. So how we are going to minimize the error? With the help of the cost function. So if some of you are from the, if some of you might have studied statistics or operational research or neuroscience or computer, neural computer networking or something of that sort, so you might have heard of this term, cost function. So it is used in different contexts in different fields basically. So we have different, so again, there is going to be some vocabulary and some jargon alert that I'm giving you. There's going to be some jargon, so let's see what are those jargons. So you will heard the cost function. Somebody will say it is a loss function, somebody will say it's an error function. In different field I'm talking about, right? Somebody will say in the operational research, maybe they will say they are trying to find out the objective function basically. So the objective function could be a minimization also, it could be a maximization also. The error function will be they are trying to reduce the error, and this is not very often heard term. These are two most popular, or most of the people talk about these two terms only, the loss function and the cost function. So whenever maybe one day you come up with your own algorithm, and you are solving, your algorithm is able to solve some problem, maybe with your algorithm, we may scan a photo of a laptop and we are able to get the specification of that particular laptop, or it could be anything. I mean, so if somebody comes and asks you, he's going to ask you, so what is your cost function, how you are trying to reduce the cost basically. So what we mean by cost is basically the error, the time that is going to take to solve that particular problem. That is the cost basically. That is going to cost me some cost on the time, you can say on the axis of time, on the axis of computational power. If I have a cost function which is very complex, so what is going to happen? It is going to take a lots of time, and it is going to take a lots of computation space as well. So let's say you are working for a website maybe which recommends movies. So somebody comes in and search for the genre they are looking for. Maybe they come and they search for horror movies. They just type horror, and you just have to show them horror movies which they might like. So maybe you have built an algorithm in such a way, you have a large amount of data and your algorithm, and might be you have some limited computational power in such a way that when somebody comes onto your website and they search for horror movie genre, then it might take you to show them movies maybe 5 minutes. That's how much your algorithm is taking to give them the result. So I guess that is going to be a disadvantage for you. Then you have to make some compromises, then you have to cut down few things, and you have to optimize, or you have to form your algorithm or your cost function in such a way that you can give them the result in a least minimum time possible, so that they can use that content, they can consume that content which you are serving them. That is very essential when I talk about in terms of product design. When we are designing a particular product, this is something that we have to keep in our mind. This is something we don't keep that in mind when we are solving a particular problem, but when we have a solution, so what do we do with the solution? This is what we try to do. We have a problem, we can solve that problem, that's not a big deal. But to make it feasible, to deploy that model, that is going to be a task. How do I make that feasible, that I can serve that particular thing? And maybe you have created something which is very amazing. Maybe you have created a model which is maybe maybe a person is deaf, he cannot listen, right? So maybe you have created a model, you have trained your model in such a way that if he have a camera in his phone, if he has your app in his phone, if he records like I am speaking right now, so it might convert maybe into some text, or if he understands sign language, so it might convert into some sign language which that person can understand. So if you deploy that model in your app, and if that person install that app in his phone, and his phone gets very much heated after he install that particular app, because it's taking too much computation power, and it is taking a lot of time for the conversion. Might be it is taking 2 or 3 minutes for the conversion, whatever I am speaking, and after when he is understanding. So there is going to be a lag between what I am trying to tell that person and what he's interpreting. So this is something which you have to keep in mind basically. So yes, definitely you'll be able to solve this problem. You might have collected the data, you applied some algorithm, you got your cost function to the best according to you, but when you deploy it, it is taking a lot of time. And that's when the picture comes in of optimization. That is the time when we try to optimize our solution. We have an answer, but we want to optimize it, we want to make it better and better, that user can use that it can be served as a product to a user. So I hope this is clear to you all. Okay, so let's jump to a Jupyter notebook and let's do some coding. Enough of speaking, let's do some coding and let's see what can we do with this. Open a notebook. So this is something which we might be doing. Yeah, so I will break down all these points for you. So today we will talk about this also, that how can I write if somebody is from academia, if somebody is interested in writing research paper using these notebooks, if they want to use these notebooks, so how can they do such sort of thing? How can they insert this sort of functions or equation in their notebook? So I'll talk about this also today. So yeah, I will break it down line by line for you so that you can understand it. So yeah, open your notebook please, and then we'll try to look at it. So let's say I want to write this thing. So first of all, what do I have to do? I have to go up here and I have to select markdown, and then what do I say? Okay, let's simply how you would say, how you would write it. So you simply go here, select the markdown. Instead of code, you select it to markdown. By default, it would be selected as code. You select it to markdown, then you type here notebook import and packages. So when I run it, this is how I get it. I mean, does it looks good? To me, it doesn't look good to me. I want to make it in this format. I want to make it, highlighted. I want to use it as my heading. How do I do that? Okay, so what you have to do, you have to go and do Shift+3. It will give you a hashtag, then space, then you go run it. This is what you get. Now it has become your heading. So yeah, you can use it this way. I can delete this. Now I have to do the imports. As I said, I'm going to make the import. So I will import two libraries, which is import matplotlib dot pyplot as plt. Okay, yeah, sure. So yeah, I'll repeat it here only. I'll repeat it here only. Okay. Yeah. So what I'm doing here, I am just simply type first of all notebook imports and packages. When you do shift plus, okay, need to select it from the markdown. Yeah, I go run it. This is how I get it. I want to highlight it. So what do I do? Go at the starting of the line and use hashtag. One hashtag if you use, then do shift plus enter. This is what you get. If you go and try using double hashtag, so let's see what happens. So this becomes little smaller. If you use more hashtag, then obviously it is going to become smaller. Oh no. Yeah, this is how it's going to look like. I want to keep it enlarged as a heading. This is what I want. So I can do this by using hashtag and a space. So if you all are able to do it, we can proceed further. So then I'll import matplotlib.pyplot as plt, and also I need numpy. Numpy is the library that I will require. Numpy as np. And also to export the graph, whatever the graphs I'm going to create in this notebook, if I want to export them, I will use matplotlib inline. So this is to export my graph. Then do shift plus enter. It will take some time to run. Okay, now let's cut this. Cut it. Now I want to write this. So how can I write this equation, this type of equation? Okay, so yeah, so let's talk about this. So again, the same thing you have to do. Example 1, I'm going to talk about a simplest cost function. We are going to do code our own cost function, and we are going to do the visualization of that particular cost function so that you can understand that what is happening in this particular code block. Just hang on, let me clear the output. Yeah, it will be better. Yep. So what I will do, I will select it as markdown. Then I will type example a simple cost. You can say function. Yeah. And then what you have to do, you have to define the function. How you define the function? F of x. Then I say, please follow the same. Now I want to highlight this. This is how I can do it. So if I want to, if I go run it, so this is not the same form that I expected it to be. So that means I need to do something else. Okay, so let's see. Let's put a dollar sign in front of the equation and dollar sign at the end of the equation. So yeah, it does make some difference. Let's put one more dollar sign. Yeah, so let's make it a little enlarged. Yeah, now I guess it's cool now. So are you guys able to do this? So this is again again another type of coding which is called latex, LATEX, latex coding. Just like we have HTTPS, HTML, if you can if you guys are aware of, if I go to example.com and if I try to do the inspect, or if I go say view source page, so you can see it has some header, HTML, it says head, then it has some title, you know. So so basically it's a structural language. HTML is a structural language, provide a structure to my my you know my the page or web page, you know, whatever I'm creating, it's provide a structure to my page. So in the same way we have latex that we can use for our Jupyter notebook. So this is a latex kind of coding that we say. Now what do I need to do? I need to code this function. This function that I have here, I need to code it. So how can I code this function? I will define f of x basically, and I will say return, when I call this f of x, return me x to the power 2 plus x plus 1. So this is my f of x basically. Okay, everybody, are you able to do this? Then do it. The code is right here. Define a function f of x and return x squared plus x plus 1. Irshad, can you see this is written here? I've written this function here. You cannot see my screen? This is the one that I'm talking about. Yeah, so just write it down. This is the function. Now what I want to do, I want to make my data. I want to have a data points, right? So I will create my data. So I'll create my data by using NumPy library and NumPy library that we have. So how do I do this? Highlighting the function is called latex. Yeah, when we do this in the markdown cell, that is called latex coding. Yeah, in the markdown cell, Yeah, this is used for more in the academia when somebody is presenting a research paper or something of that sort. You want to write down things in such a way. So yeah, this is used in that case. And if you are presenting it to maybe in a presentation which you want to explain some equation, so yeah, we also do it in that situation as well. So I guess we all are on the same page. Now the next thing that I'm going to do, I'm going to create or make my data points basically. Make data, the data that I'm going to use, because I have created a function, but where do I apply this function? I need some data points now where I can apply this function, right? So the data point is going to give me different points basically. So I will use my NumPy library that I have just imported, and I will just say np dot, when you do dot and shift tab, yeah, shift tab, then it will give you a method which is linspace. When you press linspace, you can go and read the doc string. It has 3 parameters: start, stop, and one was there, yeah, start, stop, and number. So the start is going to be the starting point, the stop is going to be the stopping point, and number is going to give me the amount of so you can see what does it do. It returns evenly spaced number over a specified interval. So this linspace, what it does, basically it returns me the linearly spaced number. So what do I need? I'll just type start, and it is going to be -3. Then I say stop. Then I say 3. Then I say num, which is equal to maybe 10. So let's see what happens when I run this cell. Now let's go and run this and check what we get. So you can see when I run this cell, I am getting 10 numbers between -3 and 3. So that means I can get any number, I mean whatever amount of data I want, I can get it by using the linspace. This is going to give me random numbers. If I say 100, go run it, so I get 100 numbers. But I need more data. So if you keep it, if you don't provide any values, so let's see what happens. So let's run it. So I get close to 50. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I get 10 numbers basically. 10, 50. 50 numbers basically. Are they 50? Yeah, I guess they are 50. Yeah. So I get 50 numbers if I don't provide any parameter, because the default value is 50. So I need more numbers, so I'll just pass in 500. I need 500 numbers. What is the error you are getting, Irshad? What is the error? Share the error with me, na? Then only I can tell. Maybe you are doing some wrong spelling mistake. Maybe you have not imported the library correctly. That could also be the reason. Share the error with me. Otherwise, we can move on. So now we have our data points, which is this. And you can see this is an array. If somebody does not trust me, so yeah, we can go and check the type. It's a NumPy ND array. So as I said, we are going to use a NumPy array when we talk about scientific calculation, when we talk about using them in the regression, or when we are building our own algorithm. So basically we are building our own algorithm for finding the gradient descent, finding the minimum cost. Yeah, I just show, yeah. I mean, you can do it, no problem in that. Yeah, you can do that. So see if I go and run it. So it's more clear now when I pass in the parameters, it's more clear for everyone that what exactly happening here. It's more clear. That's why I use this way. But if you know the parameters, I mean, yeah, you can definitely do it. No problem in that case. Okay, so shall we move on? So now we have our data points. Now what we want to do is we want to plot our data points with respect to our function that we have, which is this one, f of x. So what I want to do, I want to explain how do linspace. This linspace has 3 parameters. Okay, go to the doc string, do shift plus enter, shift plus tab, sorry, click on the plus sign, just hang on. Okay, yeah, go to this one, this section, yeah, do shift plus tab, and then oh, come on, yeah. So Irshad, go and read this doc string. I've talked about this. It's going to give me linearly spaced numbers, evenly spaced number between my start, stop, and the numbers that I want. Can we do using the maths library? If we can, then I would have been doing that. No, we cannot. Maths is for the mathematical operation, NumPy is for generating array. We cannot do it from maths. If you can, please do let me know. I would love to learn it from you. Irshad, does that answer to your question, or do you still have the same question? Read the doc string. Okay means, does that answer to your question? Yes or no? You can't even reply. Great. Lovely. plt.plot. Now I'm going to plot my data points basically. Trying to read, sir. Okay, yeah, go ahead, go ahead. But there is nothing to read. I mean, it's a very simple function. Yeah, come on. I'm passing the starting point, giving the stopping point, and then giving the numbers of the values that I want in between. If I say I want 10 values, so I'll just say 10 values I need. If I go run it, what is there to read in it? I mean, yeah, I get 10 values. If I go make it 20, I'll get 20 values. Yeah, if I go, yeah, so you can see. So you can understand it just by looking at it. I mean, does this answer to your question? Are you still stuck there? I mean, try things, put in the parameters, check the values, and see what you get. That's how you are going to learn. You are not going to remember all this. Let me put it again. You are never going to remember this until you try things, until you try out different things, change the values and check them. Because looking at the values and trying them out on your own, coding them out on your own, that is the only way you can remember things. Because there are multiple parameters that we'll come across, multiple libraries we have, multiple functions we have. Nobody can remember them. I mean, it's very tough. So we keep on trying things out. We get something. Okay, we look at the output. Okay, this is what I'm getting. Okay, let me change something. So what do I get? So in that process, we learn, right? So I'm just trying to make it, as easy as possible. How can I get values without three and and 3 in array. Without 3 and 3. Sir, I forgot. What did you say? You forgot through using? Between 3 and 3. So how many values you need, Harshita? How many values you need?
Sir,
Can
what
you?
I mean to say is,
Mhm.
like if I want to have uh, same 10 values between -3 to 3, but it should not include -3 and 3.
Okay, you are saying you should have values between. Then you need to pass. Maybe. How do I do? Hmm. You can just say 0.1. I mean, and 2.99. If
There's
you
no
want to
way
use it.
like in which we can like we have like -3 and 3 is the limit, but there are some few questions in which we have to find numbers
Mhm.
between those, but except those two numbers.
That is not possible with array, but there are different methods that we can try. I mean, there is again a random method that we have, which will give you one value in between. So let me show you, but that is again irrelevant to this, the question
Okay,
that you
so
are asking. So I have this random. So we need to explore that the question that you're asking. Obviously, there would be solution for it. I'm sure for that, and we can also provide the values maybe by using for loop, maybe by using a range function, and then we have to append those values into a numpy array. So if there is no function, we can do it on our own. You can explore this, find the function. If you don't find the function, you can create an empty array. You can use for loop. If you know about for loop, you can create a for
yes,
loop. You
sir.
can use the range function, and you can start your range from whichever point you want the value to start, and the ending point already it will be not included in the range function when we use the range function. And then you can append whatever the output you are getting, you can append that output in your array, and then you can print out your array, and then you can use it. And there is again
Okay, so
another
we have
function
to
which,
make a whole loop for that so that we can
yes,
solve
I
it.
said if there is no function for it, you can look if there is any function for it, because I haven't really used it. So I'm not sure. Maybe if I can go and explore it, maybe there would I find some function. So I can definitely let you know about that.
Okay, so thank you.
That's okay. So as I was saying, you can also use import if you want single value in between some points maybe. So there is this library that we have. This is not related to the topic that we are discussing, but as you asked the question, so NP not getting defined. So Irshad, you haven't used this line of code. You haven't ran it. Just type first of all import numpy as NP. Ajay is going to the next step already. Ajay, just wait. Let everybody come to the same pace. He already drawn the plot. I mean, that's amazing, man. Import random. Sorry, we need rand int. There is a function rand int. So I'll say from random import rand int. I guess this was the function. So if I say rand int, and then if I pass the value -3 comma 3, it will give me any value in between that. If I have a huge range, maybe 100 to 100, every time I run it, I will get a different number, and you also run it, you will get a different number. So we also use this function in some cases, and yeah, but I think we also use it in some cases, the randint function that we have. So how do we do the plot basically? So let's do the plot. Okay, if you guys can remember, we've drawn a plot basically. So I want to draw a plot, and I want the values of my function that I've created and the values that I have. So I want on the x-axis, I want my values which I have here, which is x1, and on the y-axis I want f of x. So how do I do it? Everybody please type out your code and share it with me. If you don't know, that's fine. I mean, Ajay has done it. So let's check Ajay's code. He's saying R he's giving. So this is my function basically. So I'm not getting any value on the x-axis, y-axis. Why is that, Ajay? I need the value of, I need values on x-axis as well. So he was using this parameter, which I don't know what is it. If he can explain what it does basically. So Ajay, can you tell us
Dash
what
dash,
is
yeah, dash dash is only used to put the line in dash dash line.
dash dash line means? That means you will
Dash
not
dash
have
line, dash line, dash line.
this one.
No, no, that red one.
Okay, okay, okay. Dash
The
line.
red
Okay,
one
okay.
can be appeared as a dash line.
Dash line.
Yeah, yeah.
But I'm not getting any numbers here on the y-axis. Why is that?
I'm just trying.
Okay, okay. I mean, that's great. You're trying at least. So I need numbers on this axis. So maybe I'll use a blue color. So now I want to tell what exactly I have on the x-axis. What do I have on the y-axis? So let's see how can I do it. So if you can remember, so you guys tell me. Ajay, you will not tell, okay? Let them answer this question. So I want to write, what do I have on the x-axis? I have the values of x. As you can see, they are starting from -3 going up till 3 on the x-axis, and I have the value of f of x on the y-axis. So how do I write this? Ajay, you will not showcase your code. Let them think and let them reply. Please, everybody, you guys should reply to this. Yeah, what should I type? Give me the exact code, Harshita, and all of you. I need code from all of you. So what I want is, I want the value, I want to mention what do I have on the x-axis. Like if you can recall, go back to your high school days, how do we draw graphs basically? So we tell what do I have on the x-axis. We tell that maybe the money is on the x-axis, or maybe the groceries are on the x-axis, y-axis, something of that. So x label and y label. Yeah. So what should I write? Tell me. Give me the exact code. I need the value. Just type in there x values in on the x-axis and y values, f of x is on the y-axis. So that's what I want. Harshita is saying this. So tell me one thing. I just want to know one thing, and I want a reply from everyone. Can you do that? Can you be honest? If I ask you one question, can you reply to that with honesty? Is it possible to expect honesty in a reply? Okay. So my question is, how many of you go back after this class to whatever we have discussed, whatever we have done in this class? How many of you go to the notebooks that we have created and try to change the values and try to see what exactly we are getting when we are trying to change some values? How many of you do that? Or forget changing the values, forget, just how many of you go to the notebook and read them and see, try again creating your same code by using the same code, maybe copying it in another notebook and trying that? How many of you do that? Forget about exploring, just leave exploring things and all. Please answer this question, and I expect honesty from all of you. You do, okay? What about the others? I won't reply from everyone. Then only I'll continue. So we have 10 people here, so I need 10 replies. 1, 2, I do sometimes. I do 3 replies I have. What about the others? Still, I mean, yeah, still 7s are there, okay? Get back to the part which wasn't understood, not everything. Sometimes. I do twice till now. So that means you have gone through the notebooks. What about the others? I have like, how many replies I have? 1, 2, 3, 4, 5, 6, 7. 7 I have. What about the others? 3. I know Ajay does, but what about the 2 of you? Who is left? Piyush Raj. So if you are going through the notebooks, then I think this should be clear to you all. You know how to plot or how to insert the value on the x-axis and how to insert the value on the y-axis. This is nothing. I mean, like, if you go through the notebook and try it, I mean, if you try it twice or thrice, I mean, then you will memorize it. I mean, it's not a big deal. Okay, so let's come back to the topic. Ajay gave the whole plot to us. Okay, Ajay, we'll break it down. I have it already. I mean, that's good. You are doing it. That's very good. Yeah, it's a parabolic function. Absolutely. Yeah, I forgot to talk about this. This is a parabola. If somebody you can remember geometry, then this is a parabola, basically, that I have here. Parabolic function, as we say. So let me try the code of Sunidhi. X label. Okay. What is happening with this code, Sunidhi? Why we have these dots here? Let me try Syed's code. Yeah, I mean, it's better, much better. F of x I have, and then x I have. Enter label name. Okay, you are giving me to enter the label name. Oh, I see. That's nice. Okay, great. So I also want to add the title. So how can I do that? With the help of title. So I'll just say plt dot title, and then I'll say cost function versus x. Cost function versus x. So maybe I can give it a font size. Give it a font size maybe a 15. Yeah, it looks better. Now I want to limit these values. I want to use xlim and ylim. So how do I do it? I have values. Yeah, let's see. I'll say plt dot xlim, and I'll pass in the value starting from -3 up till 3. Yeah, so it was clear already. So I'll say plt dot ylim. I'm limiting the value for y also. So maybe I need the value starting from 1. Let's see. Try it from 1 and take it up till 9. No, that means it's negative also. Negative values are there. No. Yeah, it's much better. So now my function is much better right now. I have this f of x here, font size, let's make it a little bigger, then title make it 20 maybe, and make them, yeah, and make it 16. This also 16. Yeah, so we've plotted our cost function. Now next thing that we are going to do, we are going to calculate the derivative of our function basically. So we are going to create a derivative. Now we'll say slope and derivative. Slopes and derivative. So here is a challenge for you. If this is my function, f of x is my function, I need to create a function again for me, which is going to be df of x, and it should return the derivative of this function basically that I have here. So Ajay, you will not reply. Sunidhi, you will not reply. I need a reply from others. Somebody is aware of this slope. I'll tell you why do I need this. I'll tell you about this also. Don't worry. So tell me please, how can I define a function which will return the derivative of f of x? Do you guys know derivatives? What happened, guys? I need responses. Yes, so calculate the what is going to be the derivative of x square plus x plus 1? What is going to be the derivative? If I have this function, if you calculate the derivative, yeah, so just return this value 2x plus 1 exactly. Yes, so return it now. This is what I need now. I'll just say if somebody pass in the x value, which is this value that I have here, if they pass this value, what I need to return is return 2x plus 1. You already know it, how this is working out, right? Now I have defined my function basically 2x. I'm getting an error. Yeah. No, not required in closing braces. That will work. So this is how I can do it. Now, why do I need this derivative term? Let's look at this. Let's look at this graph. Okay, what is happening in this graph? So this is my cost function again. This is my cost function. So what do I want to do with cost function? Please tell me what exactly I want to do with cost function. What we were trying to do with the cost function. Please tell me what we were trying to do with the residual sum of squares. What we were trying to do? Optimization is the second part. I mean, first of all, what we want to do? Minimization. Exactly that. I want to minimize the value. Right, right. We want to minimize it. So where is the minimize value? It's here, na? It's 0 here. As you can see, it's close to 0. This is my function, na? So I want my value up till here going. So how does that going to work out? So if you see here, if let's say I am at this point. So if you see, I want to go to this point, basically, I will use a slope. So if you check the slope, the steepness of the slope, is it increasing when I'm going downward, or is it decreasing? The steepness of the slope. Is it going to give me a higher value when I move downward, or is it going to give me a higher value when I move downward? What is happening? So slope is the rate of change. So simple. So the rate of change is high here, or is it decreasing downward? Is it increasing downward? And what is it at this point? What can you say, looking at this picture? What can you say about this? Tell me, guys. It's increasing upward. So is it decreasing? That means it's decreasing downward, right? So you can see the steepness of the slope. It is decreasing when I go downward. You can see it's becoming less and less steep, basically. You can see it's very steep at this particular point. It's very steep. But when I go downward, the steepness is decreasing. It's decreasing more. And at this point, the slope has become 0. The slope has become 0 and the cost function is 0 at this particular point. And this is the point where I want to reach. I want to reach to this point where my cost function is minimized, where it is 0 or close to 0. So how would I do that? I will do that with the help of a slope, basically. So for that, I also need a slope, right? So I will now, what I need to do, I need to plot a graph for the slope. Okay. So the next thing that we are going to do, we are going to plot the graph for a slope, basically. So I guess everybody will agree to this, that why we are doing what we are doing. Okay, let's leave it. Let's not superimpose now. Let's create my graph, which is my second graph, which will have the x value and the slope, which is dx of x. So what should be the code for it? Please tell me. Please tell me what should be the code for it. Nobody? Okay, Ajay, you tell me. What is going to be the code for drawing the slope? I want to draw the slope. df of x that I have here. Okay, why do we take derivative? Okay. So basically, if I am at this point, I need to go downwards, na? So how can I do it? I need to check at which point my slope is decreasing. And as I can see, when my slope is decreasing, my function is also decreasing. Cost function is decreasing. And there is a point where my slope is 0 and my cost function is also 0. You can see the steepness of the slope is decreasing as I go downward, and you can see the value for the cost function. It's decreasing downwards. If I go upward, the cost function is increasing and the slope is also increasing. Is it clear, Kompal? Okay, cool. So Ajay, please tell me, how can I calculate this? How can I draw the graph? Okay, I
No
will
idea
open
how
my.
to draw the graph.
Okay, no idea, but it's the same now that we did. The arguments are different here. In this case, we
No,
provided x value and the function value, right? And in the second graph that I need, in that case, I will provide this value for the x, the points that I have, and the second argument is going to be this function that I have created, the derivative.
uh,
I need.
I thought I should draw a line at
Oh,
minimum.
it will
So,
draw a line. If you draw the graph, it will give you a line, now. Just plot now. Just
mm,
put the code and you
mm,
will get the same answer. At least
okay.
just give it a try,
Mm,
right? So if I do this, so you will notice, okay? So we'll do it one by one so that everybody can understand this, what exactly happening here. Plt.show. So let's see. Now my x is going to be my data points that I have, and this is my derivative. So I'm passing the data points that I have, taking the derivative of each and every point. This is what I get. So the line that I was talking about, this is the line. Ajay, you can see we get a line. So I'll give it a color maybe of give it a color for sky blue. Sky blue would be better. And maybe line width. What was the line width of the last graph? The line width is 2. So I will use the same line width. Line width is 2. Then somebody will come and tell me, how can I plot how can I mention about this is my x-axis, what do I have on the x-axis, what do I have on the y-axis? I guess nobody's going to do that, so no issues, I'll do it on my own. So what is the limiting value? So let's leave them for now. So what do I have on the x-axis? I do have the same on the x-axis. What do I have on the y-axis? I have the derivative df of x, and this graph is between the slope of the cost function versus x. So let's run it. Yeah, great. So now I have this graph basically. So next thing that I'm going to do, I'm going to put them side by side basically. I'm going to put them side by side. Superimpose the gradient descent. No, this is cost function. Because this graph is at this point and this graph is at this point, so I want to use them side by side. So what do I do? Okay, let's see. What can I do? So first chart that I have, let's call it to be chart 1. Chart 1, and this is for the cost function basically. So I'm just gonna just copy the same code that I have written for the cost function basically, put it right here. One more thing I would require, yeah, I'll talk about this in a second. The second chart that I need, this chart is going to be chart for the derivative or a slope of a cost function. Chart 2, which is for the slope of the cost function basically. So what this graph is going to look like, this graph is going to look like this. Let's delete these values. Do I have some values for it? Derivative, yeah, I have the values in between -3, -2 to -3, -2 to -3. Then what do I have here? -3 to -6. -3 to -6. Yeah, and I also okay. Something bad just happened. No. I need the values in between. Okay, let's leave it for now. I mean, we'll look into it. What the values can be. Let's use the plt.grid because we want to check what is the point at which my derivative is 0. So this is telling me at this particular point my derivative is 0 at this particular point, right? So what I was doing, yeah, second chart, I'm going to plot it here. Now I will introduce you to the new term. First of all, I'll give it a figure size, plt dot figure. I guess that's the figure size. Figure, then I type the figure size. Call it to be 10 comma. Okay, no, not right now. I'll use it later maybe. First of all, no, I should use it. Then you can relate it. Okay, let's give it 5. And you need to use another function which is plt dot subplot. Plt dot subplot because I want them side by side. So it's going to be 1 to 1. So what is this 1 to 1? So what I'm asking is to give me a graph which will have 1 rows. That means they should come in the same line. There will be 2 column. That was the 2 says. There will be 1 graph, then the second graph. So it will be a column. Now what is this 1 says? This says first graph should be of the cost function. For this, I have to do this. PLT should show. Now let's run it. So yeah, now I can clearly see that there is a point which is close to this one. At this point, my cost is 0. Let's make them better. They're not looking so good. Let's increase the size, make it a 20,5. Then let's see. Not that good. Call it this. Not that good, man. What was the size I was giving here? 20,5. Yeah, 20,5 would be. Give it 20,7 maybe. Yeah, it looks good. Now I have both of these graphs side by side basically. Can you see? They are side by side. So did everybody able to do it? If not, I'll share the code right away. Everybody please draw this graph so we can move on to the next section. Have you drawn? If you have drawn this graph, please let me know. Okay, subplot. Yeah. So Sunidhi, subplot is used if I want two graphs side by side, basically. Okay. So it B passes. Okay, let's read the doc string. So in the subplot we have these n rows, n columns, and the index. So what does it means? It means at this point I have to pass the number of rows. So I need one row. This is going to be my row now. This is one row. I need two columns because I want to fit two graphs up here. And the last one parameter is for the two. Okay, let's do this. Okay, let's make it 2 and let's make it 1. Then you might notice the difference. I hope you notice the difference. Can you notice the difference, Sunidhi? Can you tell me why it is happening? Great. So this 1 and 2 is for the positioning of the graph. Yeah. Yeah, so I have it reversed. Okay. So I hope this is clear to you. Now I want you to try that. How can I make this graph one over other? Maybe I have the cost function graph at the bottom, then I have a graph on top of it, which is of the slope of a cost function. So just do it. And let's do one thing. Let's take a break for 10 to 15 minutes. And once we come back, then we'll look into for loop and we'll create our own gradient descent. And how can we create our own gradient descent? We'll look into for loops, while loops, how do they work, then we'll create our own gradient descent and try to find the minimum value. To merge the graph, merge the graph 1 to 1. Merging, we don't really require merging. I mean, you can try. We don't really require merging at this point. The code is shared. The code is there in the this notebook. I cannot share. Once the session is over, then I can share. Whatever I'm doing side by side now, so that everybody can follow along. That is the motive. Okay, so let's take a break, everyone, and be back by what time is it? It's 35. So be back by 40, 50, yeah, 12:50. And then we'll start a discussion on the gradient descent, for loops, while loops, and we'll create our own gradient descent and we'll visualize that how we are reaching to this point basically. And I'll have a little story for you. I'll talk about the story as well to give you an idea about the gradient descent. How this gradient descent is working, why we are using it, I'll talk about this. Okay, guys, so can we start? Everybody's in? What about everyone else? Are you guys in? Can you hear me? So we can start, right? Please type yes or no. Okay, let's start. So how many of you likes mountain? How many of you like mountains? Like to be in the mountains? Okay. What about the others? You don't like mountains? Neha also do. Me, okay. So I can assume that everybody out of you like mountains. Okay, let's look at a story. Okay, so let's imagine that you are in this mountain. Basically, it's a mountain of Australia. You are in this mountain of Australia. You went for the for some vacation, and you are living at this particular area. So now, so there are always good thing about the mountain, and there are bad things about the mountain also. So the good thing about the mountain is the weather. They have a very pleasant weather. And again, the bad thing about the mountain is the weather. That is it is unpredictable. You cannot predict the weather of a mountain. One time it is like a sunny day, the next moment it could start raining and snowing and all that. You cannot predict that. It is a very unpredictable weather when we talk about the mountain. So let's say you are in the mountain and you went for skiing basically, and you are doing skiing and you are enjoying, and then suddenly what happened, as I said about the weather, suddenly the weather changed basically, and the weather changed and you just flew away to some point basically, and you are far away from your crew with whom you were skiing before. Now you are at a point, and you are on the ground, you are lying down on the ground basically, and the cold is getting into your jacket, whatever you are wearing, you are feeling very cold at that point of time. Now you are also very scared because there is a huge storm which is coming on your way, and now you are imagining about your hotel that you should be there, you shouldn't have come to this place for the skiing and all, and you are imagining about the cup of tea or coffee you should be drinking, you want to go there. So what is the thing that you would do if you want to go to the hotel, back to your hotel? What you should do? So yeah, this is a little different basically. This is a okay, let's come to the analogy first of all. So what you should do, or what you will do if you want to go back to your hotel, how you are going to go to your hotel, what you should do. If you are on top of this mountain, let's say you are on top of this mountain and maybe your hotel is down the lane somewhere here, so how you would come to this point basically, what you will do, you want to come to this point, and how you are going to come at this point basically. Please tell me. If somebody can unmute yourself, you can speak. If you cannot, you don't want to write it out, you can unmute and speak for yourself. No response. Are you guys hearing did you guys heard what I said, what I asked you? I asked you a question and I should not expect an answer. Okay, cool, that's fine. So what you should do basically, I will be hiding ourselves somewhere. No, you want to come down. If you will hide yourself, you don't know how for how many days that storm is going to be there. I couldn't hear the question. Okay, so I said you are in Australia, you went for the skiing and you lost from your crew, and you are at this point basically. You fell down on this point, and the storm is coming, and you want to go down to your hotel. Your hotel is this way. You are at this particular point. You want to come down, go to the valley where you have your hotel, because the hotels are always in the valley. They are not on the top of the mountain basically. So what you should do, Neha, if you want to go down to the valley where you have your hotel, what you will do? That's what I'm asking. Should I speak in Hindi if this is not clear? Check for safety. Try to find the route originally you came. Okay. But you don't have that much time to find the route from which you came. You need the short. You are at some other point. You might have been that you are at this point. Now after you lost from your crew, you are at this point. So you're very far away from that point. But you can clearly see your hotel from this top. You are at this top. You can clearly see your hotel. It's somewhere here. You can see it. So okay, so I'll tell you if I would be at that position, what would I be doing? So let's say if I am at this position and I can see that this is a valley. Basically it is going in a downward direction. It's going downward and hotels are somewhere here. So what I will do, basically I will look for the steepest path, and this is not a mountaineer advice. Don't take it into consideration when you get stuck. Don't do this. Don't repeat at the mountain or home. So what I will do, basically I will look for the steepest path, because the steepest path is going to be the shortest path, and I want to reach to my hotel at a short by covering the shortest distance and shortest time. So I have to take the risk to follow the steepest path, and I have to take small steps so that I do not skid on this mountain and I landed up somewhere, striking my head on this rock or somewhere else. So I'll take a small step, and every time I take a step, I look around that which is the shortest path I should take, and then I move forward. If I come at this point, I look around myself and I check the shortest distance, and so on and so forth. So that's how I move, right? So this is how we deal, or this is how we solve this problem in our real life when we are stuck at the highest point of a mountain or somewhere at the mountain and we want to go to the valley, to the lowest point. This is how we solve this problem basically. So Neha is saying she will try to capture someone's attention. Neha, there is a storm going on in the mountain. Nobody is going to be there for catching your attention. So this is the kind of function which is the concave function basically, but we don't need this function because we will be not coming this way. Basically we'll be the mountain will be like this. Our mountain is going to be like this. I might be at this point and my hotel would be at this point. So this is a convex function. It's in 3D basically, so that's why I have it here. So it's a 3D image. It has 3 axes basically. So I am at this point basically. I am stuck at this point. So what do I do to get to the mountain basically? So I will be taking small steps basically, small steps, and then so on and so forth. I'll be reaching to this point, and this is what my cost function is like. This is, you can just relate to the analogy that I gave you with the cost function, and this is how the cost function works. If my cost function is at this point, I want to go to the shortest, I want to cover the shortest distance. How can I do that? I need to check the slope with the derivative. I need to calculate the slope which will be steepest, that will be my shortest distance. The slope which will have the higher value, that will be the steepest path, you can say, that I should be following. So I will follow that path. I will take small step. Now if I'm at this point, I will again, every time I'm taking a step, I am checking the slope again and again so that I don't make mistakes. I don't land up somewhere here, or somewhere here. I don't want to do that. So every time I'm taking a step forward, I am checking my slope and then taking a next step forward. So as you can see, my step size, as I get closer to this, my step size is decreasing. I'm taking very small step. In the when I was at this top, I was taking large step, you can see. But as when I reach to this point, because the slope is getting very small at this region, the slope is very small, so I will be taking small step, and then I will reach at this particular point. And this is the point where my cost function is minimum. So you can imagine this thing, finding the minimum cost function, climbing down a mountain through a valley. Basically, we want to follow a valley. This is a kind of convex function that we have. So the our cost function, it will be a convex function. Sorry, yeah, it will be a, yeah, it will be a convex function basically. So I will be following this path by using the derivative, checking the distance, which is the least distance, or you can say which is the highest slope. I will be covering that distance, and then I will be reaching to my point, which will give me my least cost or zero cost. So do you guys follow this? Do you understand what I'm trying to tell you? Do you guys follow this analogy? If anybody have questions on that, now is it clear why we are using slope? Is it clear? And this is how the slope looks like when we have features more than 2 dimensions. Basically, the slope that I have here, which is parabolic in nature, is because I have only single variable here. I don't have multiple variable, I have single variable. Find slope and derivative. Cool. Now what I want to do, I want to go down to this slope basically. So how can I do that? For that I need to use a concept of Python, which is for loop, because I need to do different iterations, and then I need to check derivative at each and every point. So do you guys know about for loop, or should I explain you about the for loop? For loop and while loop I'll be using. Okay, cool. So for loop is basically used for the iteration. Okay, so this is a gradient descent algorithm that we'll be designing. So somebody was asking, can I code my own algorithm? Yes, I said you can, definitely you can. So that is what I'm trying to do. Python loops and gradient descent algorithm. So this process, yeah, I forgot to talk about this process of climbing down the hill, reaching to the minimum valley or the minimum point, is called the gradient descent algorithm. Or somebody say it's a greedy algorithm. We are very greedy to find the minimum cost. Somebody says it's a greedy algorithm, somebody says it's a gradient descent, because gradient means slope means derivative. So I hope you follow this. So if you now go somewhere online, read a blog about the gradient descent, and this is the approach almost all the algorithm follow this approach. They will have a cost function which they will be trying to minimize, and most of the time you will heard that I'm using gradient descent, I'm using a greedy algorithm to reduce my cost, to minimize my cost. Most of the time you will hear this term, and we are not aware what exactly this terms means. So now I believe you all are aware, and you can, if somebody asks you this question, so you will be able to answer this question and give them a very good answer by giving them a very good analogy about this. And also if they ask you to code it, definitely you can, without using any library. So we are only using NumPy for doing this, and just by using for loop we'll be able to do that. So let's take an example of for loop. So have we covered range function? What does the range function do? So let me talk about the range function. So how does the range function works? So the range function, have I talked about the range function? Please tell me yes or no. If somebody is not aware, then I'll talk about this. Is it covered or not? No, it's not covered. Okay. So this range function takes in 3 arguments basically. It takes start, then it takes the stop, then it takes the step. So what do I mean by this? So let's put in the value and let's see what I mean by that. So I think Helena was asking me this question, so some part of that question could be answered through this. So I said my starting point is going to be 0 and my ending point is going to be 10. If I go run it and if I go and check my A, so I will have values starting from 0 going up till 9. 10 will not be included. If I want values starting from 1 going up till 10, so it will, if I want values up to 10, so I might have to use 11. Now if I go run it, now you might be thinking, what does this parameter do, which is 2, step size 2. So if I pass, now the default value is 1. If I say 2, then this is what I have. So by using this function, what I can do, I can get the even numbers, the list of the even numbers through it. So yeah, I can also get the odd numbers. Yeah, so this is possible. And this is the, I don't want you to indulge to new terminology, but if somebody can understand, this is a kind of generator, as we say in Python. So generator means if I am using it for loops, I can definitely use it. I don't need to store it somewhere. As you can see, I have to explicitly store it by assigning it to a variable, but by default it doesn't require any memory. It uses the dump memory or the residual memory, as you say. So I can use it for iteration. Now what do you mean by iteration? Somebody will ask me, so let me clarify that. So yeah, these are the values for A. Okay, let's make them more. These are the values for A. I want to take out all the values, print them one by one. What do I do? In that case, I will do iteration. So I will say for I in A, then I will say print I. Now what is this I? This is just a variable. What is this in? Okay, I'll tell you what this in is doing. What is this A? This is the list basically. So what is happening here? Let's try to look at it. So when I'm saying I in A, so basically this for loop is going into this list and checking the value at the first index or the 0th index. So it's getting value as 0. It's going to take that value, print it out. Then it is going to go for second value and take that value 1, it's gonna print it out, and so on and so forth. It takes all the value in that list. So when I run it, we will see this 0, 1, 2 up till 10. So whatever value we had in this list, we could print them out. So what if somebody says, what if we want to get only take a square of these values? Yeah, so it's possible, you can take a square, that's not an issue. So yeah, you can take the square. If somebody says what I want to add 1 or maybe add 2 to each value, yeah, so you can do that, that's not a problem. Somebody says I want to subtract maybe -1, I want to do, yeah, you can do that, that's not a problem, I guess. And if you want to +1, so yeah, also that's possible. Yeah, so this is what I have. And if somebody says, can I get even numbers from this list, then I will say yes, it is possible. in that case we have to use if else statements. So I was thinking not to introduce, yeah, I should introduce because I'm using it here. Yeah, so yeah, I have to introduce this term. So what does this if do? Now we are telling the program, if this happens, do this, right? That you how do you make your plan? Like you might make a plan, if it is going to rain, then this is what I'm going to do. If it is going to be a sunny day, this is what I'm going to do. Maybe if it is going to rain, then you might stay at home and maybe binge watch Netflix, or read some books, or explore your art that you like. And if it is going to be a sunny day, maybe you can have a plan visiting out, maybe going for a movie or something else. So same way we are telling the Python, if this happens, do this. So what do we want to do? I guess I've introduced to this modulus operator. Do you guys know about the modulus operator? What does it do? No. Okay. So okay, let's see. So okay, first let me break it down. So if I divide 5 by 2, what should I get? I will get 2.5. So it will go to 5 and check the value. It's 4, then 1, then point, then 0, then 5, 2.5. What if I only want the question? What should I do? You can do this. It will only give you the question. Now somebody comes in and say, sir, how can I get the remainder? Surely you can. You need to use the modulus operator. If I go run it, so you can see this is the remainder. So why you are telling me about this? What should I do with this? Okay, yeah, hang on. I will surely tell you about this. So what if I want to check if a number is even or if it is odd? Okay, let's see. So if I go and divide 4, take the modulus of 4 by 2, what would I get? I will get 0. So if the remainder is 0, that means that number is a even number. If the remainder is not 0, then it is not a even number. So keeping this thing in mind, I can design a for loop on this concept, that if in my list, if I have a number which is I, and if I divide I and if I divide I by 2, and now there is again another thing, equal to. So in Python or in programming paradigm, if I say a is equal to 5, so that means I am doing the assignment. Now I guess you are clear with the assignment. If not, that's completely okay. So that means if I go run the value for a, I get 5. That means the value 5 is now assigned to a. Now what if I want to do the comparison? Now what is comparison? Means comparing two values. So if I go and put a equal to 5, so I will get a boolean output. So it is going to compare the value of a and 5 maybe. So value of a and 5, are they equal or not? Are they equal or not? Type yes or no. This is the answer I can expect from you. Now you can answer this question. It's not tough. Please respond. Yes, so I will be getting true. Okay, let's run it. So I am Sunidhi saying it's false. How, Sunidhi? Why is it false? Please shed some light on it. We would like to know why is it false. Sunidhi, sorry. Okay. So now if I compare it with 6, I will be getting false. Now double equal to is used for comparison. If I want to check if this value is not equal to, yes, equality operator. Now we have another operator which is this. So this value, this says that A is not equal to 6, which is true. If I go run it, I'll get output as true. But if I go check it for 5, I'll get false because A is not equal to 5. It is equal to 5 but not equal to 5. So there is a difference. So do you guys follow who says they are not from the computer background? I mean, it's very clear, I guess. Do you guys follow this, whatever I'm saying? This is not alien to you, right? I'm trying to make it as simple as possible. Great, great. Lovely to see your responses. So I'm just going to say, if the value of I, now what is this going to do? If the value of I, if I get 0, if I divide 0 by 2, so if that coming out to be 0, the remainder I'm getting 0, and then print that particular number. So the indentation you have to keep in mind, otherwise it will lead you to the errors. So int object is not callable. Why it's not callable? Yeah. So you can see I am only getting the even values now. Now, what if I want to get the odd values? So what is happening here? Let me explain it to you. So for loop is going for each and every value and checking the value. Now, when it is at 0, it is going to go. Okay, let's forget leave 1. So let's see if it is at 1, it goes and try to divide it by 2 and it gets remainder 1. It don't consider that value. It don't print it, right? It doesn't print that value. And if it wants to, now it goes to 2, it divides that, it gets output as 0, it prints that value. It goes to 3, it checks it, it gets non-zero, basically it gets 1, so it leaves that value. It goes to 4, it checks the value, the output is basically 0, the remainder is 0, it will print it, and so on and so forth. So I can also add a string here. So maybe I can say this is a even number. Yeah, this is even number, and other numbers apart from this I can use a else block in which I will say print maybe we have odd number at this place. So it is going to go for each and every location. Guys, can you hear me? There was a glitch on the internet. I hope I'm audible. So as I said, you need to make sure for the indentation, this white space acts as a indented block. It tells Python what to do after what step. This semicolon is going to recognize the indentation. So what you should do that you can make sure you don't make any mistakes. So if you are getting any indentation, just take back this code at this point, and then after the semicolon, press enter. Then take the another line of code backward, put it in front of semicolon, then press enter. Take this back. I mean, it's fine, I mean totally, but yeah, and it should be under, else should be under the if. basically. They should have the same spaces. If you have a problem with the print, take it back. Great, it's done. Great. So what exactly this code is doing? This is telling me that 0 is my even number, and whatever the number, oh my bad, yeah, so 1 is not a even number, it's a odd number. We have odd number at this place, so you can play around with it and print out anything that you want to print. Maybe you just want to print this, maybe you want to print even only for whichever value, so it will be not okay. Yeah, I have to pass it in a string. If you will pass it without string, it will give you an error. So it doesn't make sense anyway, but yeah, this is also can be done. Yeah, 0 is even, 2 is even, and so on and so forth. Okay, so then we have this is for loop, if else if elif state. Then we can pass in multiple elif also. So I will leave that for now. I guess it's going to be very much tough if I try to explain it to you. So elif means we can have multiple arguments in between. Maybe I can say elif. I can pass something else. If this happen, I can have some condition, then this would happen. Maybe I'll say print odd is there, some things, you know. So it's going to give me an error. I need to pass in some parameter. Maybe I am checking for yeah. So it's saying 0 is even, or I can modify this. Even number is, or I can put it in different direction also. Maybe I'll say that I'll print the number first, then I'll say this is an even number. This is a even number, and in the same way I can say to this also. So you can play around with, after class you can play around with these statements, and you will definitely learn something out of it. So this is a odd number. Okay, if I go run it, yeah, so it tells me 0 is a even number, 1 is a odd number, or odd number, I'll say this is a odd number. Yeah, so you can play around with these sort of statements, and then if nothing works out, then I can have a else block. All numbers are printed. Then once all these conditions satisfy, then I can have another block, which is the else all numbers are printed. So in this way, you can play around with these statements. You will get some errors, try to solve them, and try to make sure the indentation is correct. Now this comes under, this means I have a for loop, then if and elif are coming under the this for loop condition. So once this loop runs, it will they will run in a same fashion, basically same order. When all of this is completed, this is not, this else is not under the for loop, basically. So it is out of the for loop. If I put it here, then you might see it will give me some errors, or something else would happen. So you can see I'm not getting the output, basically, because this will only run basically once these two conditions are not met. Else condition only runs when two conditions are not met. So if you don't get it at the first place, it's okay. I mean, it takes time, and you might not get it at the first point basically. So just keep that in mind and just try to work around it. You will get it for sure. So then I also have a while statement basically. So let's look at the while statement and then we'll wrap up for today's session. I think we won't be able to cover the gradient descent. So how does the while loop work basically? So while loop, I have a condition basically. So I am setting this counter to be 0, and then what I'm saying, till the time this counter is less than 5, do this, print counting the counter. It will print me the counter, then it is going to the counter. Once now it goes there, print 0, then it comes at this point, it increases the value of counter by 1. Now it becomes 1. It comes at this point, it does the comparison, it's less than 5, it does print it. Okay, let's print it, then might be you get an idea. Now see, first of all, the counter was 0, it does the comparison, and then it prints that particular value of the counter, which was 0. Then the value get increased to 1, it goes here, does check the condition, it gives me true, that it is true, and this is a comparison operator again. This will check in this way, it will go there and check 0 is less than 5, it's getting true. So till the time this while loop gets true, it will keep running. True, it will run 3, it will run 4, it will run, when I have 5 here, it will say false. Now when I have false for the while loop, when the answer for the while loop is false, then it will not run this statement. And then I have this print which is out of this while loop, and then I'm printing ready or not, I'm here, I come. So you can say counter is 5. Now something else you can say here, counter is 5 now, or counter is equal to 5. Yeah, so did you get it what I'm trying to say? How does this while loop works? Did you guys follow this? So else is basically if this doesn't go through, then I can have, how do I explain it to you? So basically when this condition satisfy, if let's say if this is not true, if this is true, then run this condition, and if this condition doesn't work out, then do this basically. This is why we have else basically. For elif, I would say that if I want to do the multiple comparison, in that case I use elif statement. So does that answer to your question, Sayyid? Does that answer to your question? Great. So I will do one thing. I will share this code with you. Just leave this gradient descent now, and leave this one now for now. I mean, this code, the big chunk of code that we have here, leave it for now. I'll comment it out. Don't run it. I will explain this to you tomorrow. And this gradient descent, how this gradient descent is working also, I will talk about this tomorrow. So don't go and run it. If somebody want, they can, but I'll talk about this tomorrow. So I'm downloading this file, I'll be sharing it to you. So have a look and try out the for loop and elif statement. If you have any doubts, then we can discuss it tomorrow. So if you have any questions, please ask. Otherwise, I'm just going to wrap up the session. No question?
Okay, guys, thank you so much for your time. Have a great day.